Okay, this is the Unit 3 review guide, topic 9A, question 12. So we're finding a quadratic model that passes through each set of points. That means I want a quadratic equation. So I'm basically looking for a curve of best fit. That's going to be found by using my stat button in my calculator. So I'm going to go to stat, and first I'm going to edit. Whenever I use my stat button, I always need to enter the information first, and that's under stat edit. If you have information already in your calculator, make sure you do not use the delete, because that will delete your L1 and L2 columns. So you want to go up to the top of L2 and hit clear enter, and that clears the entire column. Up to the top, clear enter, and again, not delete. You are clearing, not deleting. So now I'm going to enter in these 3 points right here. So I'm going to enter all my x in L1 and all my y values in L2. So first I'm going to do my x values, which are 2, 3, and 1. I'm going to go over to L2 and put my y values in. So at this point too, you should make sure that you have the same number of values in L1 and L2. It's kind of easy on this one because I only have 3 values, but when you have a lot, you might slip, you might miss one, and you will get an error if you don't have the same number of values in L1 and L2. So always check that and make sure. You can also check your points and make sure you put them in right. So once I've entered my data and edit, I go back to stat, and now I'm calculating. I am calculating the curve of best fit. So if you look down here, I have number 5 says quadratic regression. So that quadratic, that's my curve of best fit. So I'm going to go to 5, enter, 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 enter. And it even gives me the basic form of a quadratic, right? So my basic form is ax squared plus bx plus c. It gives that to me right on my calculator. And then it tells me what a, b, and c are. I just need to plug them in. So my a value is -2. That goes in front of the x squared. My b value is 8. That goes in front of the x. And my c is my constant. So that is my curve of best fit. All from my calculator. So let's try the next example of this. So again, I need to hit the stat button first, and I need to enter my data. So that's under edit. I'm going to clear my data, but clear. So go up to L2, hit clear, enter. L1, clear, enter. Oops. Didn't actually hit clear. Okay. So now I'm going to enter all of my x values in L1 and my y, or my f of x, in L2. So I have -1, 1, and 3. Those are my x values. And my f of x, or my y, is 7. It looks like a 5. And 11. Hoping that's a 5. I guess we'll see. So I'm going to do stat, calc. Again, number 5, quadratic regression. Enter, 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 enter. And again, here's my equation. Gives me my basic form of a quadratic and tells me what a, b, and c are. I just need to plug them in. So I have my basic form, ax squared plus bx plus c. My a is 1. My b is -1. And my c is 5. Or of course, I don't really need to have the 1. I can just say x squared minus x plus 5. Okay, moving on to topic 9, ABC. This is going to use R values to determine, do I actually want to use a quadratic model, or do I want to use a linear model? So again, our first step as always is stat edit to enter in our data. So clear out your old data. Put your new data in. So again, these are my x's. Sometimes it helps to label your table. These are my x's, and these are my y's. So this is my L1, and this is my L2. So 1, 2, and 4, 32, 64, and 74. So now, question A says find the best fit linear model. So instead of stat 5, I want to be on stat 4. That's my line of best fit. And it even gives you a little hint here. It shows ax plus b. We talk a lot about mx plus b. They're using a, but this is my line, number 4. LIN for line, linear regression. So we're going to hit 4, and then enter, 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 enter. It gives you the form to stick it in. So it tells you y equals ax plus b, and it gives you a, and it gives you b. So I am going to put the A in front of the X. So I've got 12.71X, and then I have the B. Now, because I'm going to be trying to find which one is the best fit, I need the R squared value. So for this problem, my R squared value is 0.78. Now I don't need to enter my data again because I've already entered it in. My data is not changing, but for question B, instead of linear, I want the quadratic model. So I go back to stat, calc, and now I want number 5, quadratic. Enter, 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 enter. And again, this is my ax squared plus bx plus c. So I put the a in front of the x squared, the b in front of the x, and the c is my constant. And here my r squared value is 1. So when I'm trying to decide which is the best model, I want it to be as close as possible to 1, and it is actually 1 here. That means that this is a quadratic curve. So I'm going to say the best model would be quadratic. Again, I'm trying to get as close to 1 as possible, and this one is 1. You can't get any better than that. That's as good as it gets. So now I'm looking for the number of tickets sold on day 3. Day is an X value. So they're saying X equals 3. Number of tickets is Y. So they're saying, what is Y when X is 3? So I'm going to plug in 3 everywhere there's an X. And you can do this by hand like I did here and put in your calculator, or you can use the stow button. So I'm showing you here how to do it by hand because I want to make sure when you do this you're substituting in parentheses. But now I'm going to review the stow button again. So 3 stow X means that every time I push the X button now, it's going to use 3. And now I can just put in this equation here, negative 9x squared plus 59x minus 18. And again, it's the same thing that is going on down here on paper. It's just that up here, my calculator knows it's going to put 3 in for x. Down here, I did it myself by hand. When I do this, I get 78. That means there will be 78 tickets sold on day 3. And again, because it is a word problem, you should answer in words. So it's asking how many tickets. You say 78 tickets. So again, on this problem, we did both the linear one, and that was under stat calc 4 for linear, and we got our linear model and we got our r squared value. And then we did stat calc 5 for the quadratic model, and I wrote that one. And then we're comparing to see which one is closer to 1, to see which is the best model to use. We decided that the quadratic model was best. So down here, we look to see the number of tickets sold on day 3 means I'm looking for Y when X is 3. So that's also why it's helpful to label your table here, because if I label my table X and Y, when I go back and try to figure out what it is I'm looking for, I can say, oh, day 3, okay, that's in my X column, that's an X. Oh, number of tickets, that's Y.